Hello, physics guys. We are going to today talk about seeing relationship with formulas. And I saw this meme I thought was funny. It says, I have no life and I can prove it mathematically. I got that from picture quotes. That's not what we're talking about. We're not talking about seeing relationships like dating people with formulas. We're talking about, can you see from a formula how two variables relate to each other and make predictions based on that, even when you don't have numbers to put into the formula? This is a very important skill, and once you learn to use it, it becomes very powerful. We're going to use it all year long. Physics is everywhere, and this is one of those things where when you miss the physics, you do miss out because just understanding this relationship becomes very powerful. Okay, so let's go ahead look at the four types of relationships. um, the first one is direct, sometimes called linear, and that is where y is proportional to x. You say y is proportional to x, that's direct or linear relationship. You can say y is inversely proportional to x or 1 over x. That's the inverse. Quadratic would be y is proportional to x squared. Sometimes that is called a squared relationship. People use the term squared and quadratic sort of interchangeably, just like we do direct and linear. And square root, and I'm guessing you could probably predict this, y is proportional to the square root of x. These are all mathematical relationships. We're not talking physics yet. And they can all be graphed. If you graph y is equal to x, you get a straight line. It doesn't have to go through your origin. It can be shifted around, but it's a straight line. Inverse, it looks sort of like this. Again, it can be shifted around a little bit, but the idea is it has that curve to it. X squared will go up like this, and square root looks sort of like that. And again, these can be moved around. We often draw them from the origin, and I should probably draw that one from the origin so it looks a little neater. But um, you can, depending on your situation, doesn't have to be. It could be shifted. Okay. We are not going to focus on the graphs in this video. They are important. We will deal with the graphs quite a bit. But in this video, we are going to focus on the mathematical relationship up here, just understanding what those mean and using them in formulas. So let's go ahead and review our formulas. We have four of them, and I want to actually focus right now on the formulas, not on that question. So here we have delta x equals v I t plus 1 half at squared. I wrote that one twice. And then we have vf squared equals vi squared plus 2a delta x, and vf equals vi plus at. So essentially our three formulas I talked about from the beginning with our formula sheet and how we use them. However, we have this one twice, and there's a reason for that. Because when the acceleration equals 0, this part of the equation is no more, and you end up with delta x equals vt. And I've explained that before. What I haven't explained is this one, which occurs when your initial velocity equals 0. What happens when vi equals 0? Let me keep the red for a minute. Well, this part would go away, and you'd be left with just the rest of the equation. So delta x would equal 1 half at squared. Okay. And then we got the other two, which I'm not going to modify right now. Now let's go back to that question I had. And a car is going at a speed v for a time t. A second car travels the same distance at a speed 2v. How long did it take in terms of t? We can't just plug this into a formula and get an answer. We have to use the relationships because there are no numbers. So our first step, we got to sort of find out what type of relationship is this. And so the first thing you want to do is really to read the question and identify what it is you're looking for. I'm looking for how long. That is a time. In terms of t, is a big clue, time. And what has changed? Well, it's the velocity that's changed. So I need to relate time to velocity. Um, there are two options for that. this has a velocity and a time in it, and this has a velocity and a time in it. So we probably are not going to use this equation. There's no velocity in it, so we know that equation has no velocity. This equation has velocity, but doesn't have time, so that's a no-go. The clue here is if it were accelerating, I'd want this relationship. So if there's an acceleration, I'd go here. And with no acceleration, we've already implied a equals 0. We use this one. So if a car is going at speed v for time t, is the car speeding up or slowing down? No. This is going at a speed v. This has no acceleration. So our equation is delta x equals vt. So that's sort of the first thing we do. We read the question, we write down our equation. The second thing we want to do is solve it for the thing we're looking for. How long? And you solve this for time. So that involves rearrange, sorry about that writing, for time. We're going to divide both sides. Let me change colors. We're going to divide both sides by v so that I can get t on one side of the equation by itself. And I'll put t here. Normally you'd write it on the left, but I'm going to put it on the right so it's a little bit out of the way. So the delta x over v I'm putting over here, delta x over v. So that was step 2, you rearrange for the unknown. And then what we do is we write it as a proportion, making anything that is constant or not part of the problem a 1. Okay, now what is constant? The distance. So it said here it traveled the same distance. So you know what delta x is going to be? It's the same distance. It's going to become a 1. Anything that stays the same just becomes a 1. We write it as a proportion. T is proportional to 1 over v. So we made our proportion in step 3. Now we have to identify which one of those that is. Do you remember? Let's go back. What does that look like? That looks like, 1 divided by, that's inverse. So we identify our relationship as, we write it this way, T is inversely proportional to V. T is inversely proportional to V is the same thing. These are equivalent statements when I write T, that symbol, 1 over V, and I write out the words T is inversely proportional to V. They mean the exact same thing. We want to now answer our question. I haven't answered the question yet. A second car travels the same distance at a speed 2v. Okay, so let's go ahead and I want to put the original parameters in green. Okay, some went t and it went v. So I know t is proportional. I wrote an equals there. T is proportional to 1 over v. Now let's get the new one out. Okay, I'm going to call this t new, N for new. It's also proportional to 1 over v, but it has twice the speed. Remember, the new one is going 2v, so 2v. Okay, lovely. I want to make a substitution. Remember, 1 over v is equal to t. So I can take that part and say that's equal to t. The 1 over v is same as t, it's proportional. What I'm left with is the 1/2. So the t new must be equal to 1/2 the old t. And so that's the answer. Now you can probably get that without going through this little methodology here. If you think about it, if I drive 60 miles an hour to work, and the next day I go to work driving 120 miles an hour, am I going to get there sooner or later? Well, it went twice as fast. It's going to take half the time. You can maybe reason through it that way. We do want to see that you can understand these proportions because they're not all quite that simple, okay? The other thing that you can sometimes do, you got the t is proportional to 1 over v. What if you just said replace the v with the 2? Your answer, it's going to be a 1/2. It's an effect of 1/2 as much. You can sort of see that there. Here's another one. A ball is released from rest and rolls down a ramp at a constant acceleration. A constant acceleration, if it doesn't change, that equals 1. It arrives at a final velocity vf after a distance d. How fast would it be going if the distance were triple? Okay, so we have a ball rolling down a ramp. After there's a ball, it's going down. After some distance d, it's at speed vf. What though if we went instead of went d, we went all the way down to 3d. So we went from here to there is 3d as opposed to right here, which is just d. What would the velocity be here in relationship to that vf? The way we go about this is the same thing. First, we need to pick us a nice formula. Now, what formula compares the final velocity to a distance? Well, this one doesn't have a velocity in it. This one has a velocity and a delta x, but no acceleration. A does not equal 0. This has a final velocity and a delta x. This has a final velocity and a time. I think we have a winner. I'm going to say vf squared equals vi squared plus 2a delta x is the formula I'm playing with. Okay. Now, what is I'm looking for? How fast? I have to solve this for vf. Okay. So that's pretty easy. I just square root both sides. So if I square root vf squared, I get vf. If I square root everything over there. One more thing I can pull out, though, is if it's released from rest, that's telling me the initial velocity is 0. So I'm going to go ahead and get rid of that vi, so that's equal to 0. So 2a delta x. So vf equals 2a delta x is the equation solved for my unknown variable. Okay? But how fast how's velocity related to distance? Anything with a constant becomes a 1. I can write this as a proportion. Vf now is proportional to the square root. That number doesn't change, it's a constant. I'll make it be 1. A doesn't change, constant, make it be 1. So V is just proportional to the square root of x. What type of relationship is this? Back to, it's a square root relationship, okay? That's a square root relationship. So I can say VF is proportional to the square root of delta x. And I probably should write out square root, but I was running out of room there. All right, so those two equations are equivalent. Now let's go ahead and think what happens. How fast would it be going if the distance were tripled? Well, if we triple the delta x, that's under the radicals can be the square rooted. So the VF will be square root of 3 times the VF new. New VF will be 3 times VF original. Okay, because it is tripled. That's where the 3 comes from, and it's a square root relationship. So it's increased by the square root of 3. If you like, I can go through the sort of that what we did before with the derivation, where if original VF e square root equals delta x, then VF new equals, or is proportional to, correct, proportional to the square root of 3 delta x, which is the same thing as the square root of 3 times square root of delta x. And square root of delta x, we said down here, was VF original. That's the original VF. And so I can write square root 3 VF original. And so the VF new is proportional or equal to square root 3 VF original. Okay. So that is how that one works. I think I have one more here. Yeah. So a ball is released from rest, rolls down a ramp at a constant acceleration. Again, constant acceleration wants the same setup. It arrives at a final velocity after a time t. Now we're relating final velocity to time instead of distance. How fast would it be going if the time were tripled? Okay, so now rather than rolling 3 times the distance, it rolls for 3 times the amount of time. Which equation? Does this one relate velocity? No. This one has velocity and time, but a has to equal 0. No. This has final velocity, but no time. We must be playing with this one. So VF equals VI plus AT. Again, the initial velocity is 0 because it starts from rest and we have a constant acceleration. So I can jump down to say my final velocity is proportional. I wrote an equals, now I'm trying to, okay, calm down. VF is proportional to, I'm going to use 1, and 1 times t is t. So VF is proportional to t. That is a direct, or sometimes called linear relationship. So VF is directly proportional proportional to t. Okay, VF is directly proportional to t. That's how we write that in words. And so when it's directly proportional, when you triple one, you triple the other. Okay, so if you put a 3 in there, you multiply, if VF new is, well, I wrote an equals proportional to 3 of those original t's. Well, you multiply the time by 3, and you're going to get 3 times as big of a number. And so t times 3 gets you 3 times as big of a VF. So VF new would be 3 VF. And that's how we do those. So you're going to now go ahead and try this with this assignment. The direction to read this scenario, write down the equation represents the relationship. Rearrange the equation so the variable that you are asked about is on the left. Write the equation with the proportion sign instead of the equals, and remove any variables that are constant, make them equal 1. So I say remove, so equal 1. Circle the relationship as linear squared, sometimes called quadratic, inverse or inverse square. So they're here. We did not talk about inverse square. Inverse square is y equals or is proportional to 1 over x squared. I don't think that shows up on this assignment. We will see that later in the year. But for right now, I'm not thinking you have any inverse squared. It's just both inverse and squared. And then write your answer. And I have the first one here to do with you. The first one is an easier one. I'll put my face up there. Okay, so car is going with a velocity v and travels a distance x. How far would it travel the same amount of time if velocity were doubled? Okay, velocity equals delta x times t, because that's relating velocity to displacement, and my time is constant. Remember, it says the same amount of time, so that's constant. We can let time equal 1. So now I know velocity is proportional to delta x times 1 for time. I need to write times 1. And so what type of relationship is this? This is a linear relationship. In a linear relationship, if you double one thing, you double the other. Whatever you do to one, you do to the other. So if I were to come in there and, and put I guess we doubled the velocity. Wait, what? Oh, I did this backwards. I'm supposed to solve for how far. So I need delta x on the left, but then you would just you divide both sides by t. So you'd write delta x is equal to v over t. Then you let t equal 1. And so delta x is proportional to v. We get the same effect. But if you double that velocity, v times 2 gives you twice as much. So 2 times the distance is my answer. My justification would be because delta x is directly proportional to v. Okay. So you're going to go ahead and do the rest of those and submit to me when you're done. And I hope that was helpful. You guys have a great rest of the day.